our warm-ups, okay, and so I want to highlight some of the main things that you needed to make sure you included. So here we go. Okay. On this one, okay, this side was one mean. So you wanted to make sure that you just had information about one mean, you had your conditions on one mean, and so we just had one average of that L3, okay? All right, so the average difference in the anxiety level is that for all of this teacher's AP statistics students. Okay, so that's what you would be inferring to from this one sample of 16 to all of them. So I have one mean here that the average of post minus pre. At some place you need to have indicated, how you did your subtraction. Okay, because as you can do the subtraction either way. So you need to indicate which way that's going to be. So it's equals 0, or we wondered if the anxiety went down. Okay, so let's look at your conditions. Since this is for one group, I'm just having to do one set of conditions, one sample. It is stated. Now, I will say that I have gotten some questions on the quiz about this sentence in it that says, assume this school is representative of all schools or something like that, and then people think that means they don't have to do any conditions. Okay, that's not true. All that's information about is what you can generalize to. I mean, if anything, it's saying that how we normally, if it's not stated, then we assume it's a representative sample. Well, it just stated that it's a representative sample. Okay, so that's all that does for you. It doesn't give you a pass to not do any of this stuff. All right, so this one was stated random. Your one group of 16 is less than 10% of all of these such students. Okay, hey, don't forget this. This is probably a common missed condition. Pairs are independent of each other. Okay, the pairs are independent of each other. All right, so large enough it was not. So you do your histogram, make sure you label. This is about difference in the anxiety. It is not an average difference right there. This is just straight up the difference numbers. Okay, and then number of students. Unimodal, somewhat symmetric, no outliers, so nearly normal model applies. Now, when we get our t-value, because it's a one sample t-test for paired data, and we just do the t-interval in the calculator, then here we have a t-score. We got our p-value. Don't forget that why do I have to put the degrees of freedom there? What's the importance of that? Correct. Tell the reader which t-curve the computations were made off of. And so since this is one sample, this is computed from n minus 1, being 16 minus 1 is 15. Yes? Your tail could have been different. Maybe if you did two tail or the opposite tail, you got like 99% or something. Yeah. Okay, so on that line where it has the options for your tails, you would have done an incorrect tail. Okay? All right, so this p-value was low, so I'm rejecting, but let's talk about this. If you are apprehensive about how to word your conclusion, I mean, big hint, spit back the question that was asked of you. So in this section that I highlighted here in blue, answers verbatim almost the question that was asked. Now this says do the data, and y'all think that sounds weird, but data is a plural. I mean, so, whatever. If it says, does the data indicate that the average anxiety levels about statistics decrease after the students take the AP statistics class? Look here. I just word for word answered that question. The data do. I put does because we just kind of freak out about that. The data does indicate that. Same words exactly. The average anxiety level about statistics decreases after students take the AP course. So big hint to you there. Spit back exactly what they asked and answer it. Okay. All right. Any questions on that test? Okay. On this interval. Okay, one thing here. Hey, you do not have the right to skip the parameter and the assumptions unless you tell me where those are. You can't just leave them off because they are needed. So tell me that the parameters and assumptions are stated above. Okay, so if you want to see those, just look above. This is a one sample t interval for means. Degrees of freedom 15, and so we did t interval. It gave us this. Now, you probably did not have this little notation here. I've not really stressed that. It's not a requirement, but this is always helpful because it really clarifies and helps you hone in on exactly the interpretation of the interval. And so by that I mean, here, this is the mean of post minus pre. So if my numbers are negative, I need to know why they're negative. They are negative because this second value of the before anxiety is higher, okay? So by thinking through this, it's an indication of your sign and what that interpretation is, because I don't want a negative number in your conclusion. Does it make sense to come to somebody and say, hey, that difference is a negative 0.628, 1628 or whatever? No, that's not a tool of communication that makes sense when you in your interpretation. So you always want positive numbers, even if it gives you a negative. Okay? So I am 90% confident that the average difference in anxiety level of all such students is between, and it's nice to go from least to greatest, 0.622 and 1.628. Since you have no sign there, you must indicate which is higher or which is lower. I just always go which is higher. I just kind of make myself just always say which one's higher. It's easy for me that way. It kind of simplifies things. So I just always say which is higher. And it's this many points higher before the course is taken. Don't be tempted to say was taken. Was taken references past data. In other words, the 16 in the sample, not the whole thing now and forevermore. Okay, or at this time. Questions on that side? Oh, yeah. And don't forget your zero statement on two means, paired data, and two proportions. Those are these last three over here on this list are always when you have to include a zero statement. Okay? These are the three that we're interested in differences. So, since zero is not intended, is not in the interval, this further supports that there is an actual average difference, one average. Okay, questions there? All right, second one. Okay, this is two separate amounts. The sample sizes are not even the same. Two separate items, two separate groups, so you have two separate means. So everything should be about two groups. Your hypotheses, your parameters are about the average GPA of all college men, and you may have included of the class because it was a little ambiguous. It was up here a little bit with the college class, something or other. So I thought it was a little unclear as to what we actually could infer to. But mu of W is the average GPA of all college women. So here you have your two, here you have your two, in your null, in your alternative, you've got your two means. You've got the mean of the men equaling the mean of the W, the women, or the question was if the women were higher. I just generally tend to kind of keep this lined up, so my sign went this way so that the women is higher than the men. Okay, however. Okay, so if this is about two groups, your condition's about two groups. Pick your stuff. No, homework 24 and 25 for Monday and Tuesday. Okay, so random was stated for both groups. And so now independent for each group I list out. 13 is less than 10% of all college men. 19 is less than 10% of all college women. And don't forget this, just like on the front where we said the pairs are independent of each other, here we say the groups are independent of each other. So the group of men is independent of the women. Nobody's in both groups. Okay, it was not large enough. Now, one other thing, I had people ask me, do I need to even do these conditions at all since they give me the histograms? Yes. All the histograms save you is having to draw the histograms. There's more than just the histograms, okay? So here is your ticket out of having to do the histograms. You say, no, they are not large enough for both groups, but I can see from the histograms above that both groups are. So you still have to interpret what information you get from those histograms they drew. Okay, you have to still connect to the histograms they gave you. I can see from the information they gave me that both groups are unimodal and somewhat symmetric, and there are no outliers, so the nearly normal model applies. Okay. All right, p-value, t-value, and oh, this is a two-sample t-test for means. Where does this come from? The calculator, because this is a horrible, horrible computation formula. Yes, thank you. This is a horrible thing to compute. So luckily the calculator gives us the degrees of freedom when there are two samples. See, over here, when there was just one sample, we did this ourselves because it's n minus 1. But over here, the calculator gives us this because it's so nightmarish. Okay, so here we go. Since our p-value is less than alpha, I reject that the average GPA of college men is the same, I know this is difficult to see, as the average GPA of college women. Now, here again, I spit back the question almost verbatim, but I answer it. See this question? It says, does this sample support her claim that college women tend to have higher GPAs than college men? So boom, here it goes. This sample does support her claim that college women tend to have higher GPAs than college men. Okay, personally, there needs to be averages in there, not just individual GPAs. That the higher average GPAs, okay. Personally, I would have put that in there, but you can't go wrong if you're just spitting back exactly what they said. I don't think. I mean, I don't see how they could penalize, if you get penalized for that. Okay, questions there. So here's our parameter and assumptions that were same as above. It's a two-sample t-interval for means, and look here. Okay, now I want to let you know how the calculator does its computation. If you were wondering, whatever you put into the 1 section, the x bar of 1, the standard deviation of 1, then the 1s will subtract the 2s. So I put the men's data in my calculator into part 1s, and I put the women's data into part 2s, so I knew my calculator was doing the men's information minus the women's information. Okay, so the calculator does the 1s minus the 2s. So since I get negative numbers in my interval, then I can interpret that this second value is the higher one, so therefore I have evidence that the average GPA for the women. So I am 95% confident that the average GPA of all college women is between, is between, and then you have your little numbers. Notice how the numbers are positive. Okay, 0.0440 and 0.818 points higher than the average GPA of all college men. Okay, and then you've got your, since the 0 is not in the interval, this further supports that there actually is a difference in the averages. Okay, so there's 2, difference in the averages. Okay. Ta-da! Questions?
What was the 0 on the first question?
Similar, except for it was that this further supports that there is an average difference. Or average, difference. Because see, it's just one average on this side. Okay? Questions? Alright, when I hand you your quiz, I need to give you some information about what you do on the quiz, because you are not going to completely do the front and the back. You're going to do part of the front and part of the back. So I'll fill you in on that in a minute. But turn in your homework 24, homework 25. I'm going to come around and stamp you for your warm-up and your reviews, numbers 1 through 4 you did. Homework, do not turn in the review. Make sure you don't turn that review in. Your homework tonight is numbers 5 through 10 on the review. Okay? Piecing you through that number 5. And by the way, on the review, if you kind of freaked out on number 3, it was a proportion problem thrown in at you. It was a I think it might have been 2 proportion z-test. Okay? So, ta-da, a little different thing to think of there. All right, here it comes. On your desk, just have